All right, so today, this is most likely going to be our last lesson in terms of class material. Today's Thursday, May 28, 2020. We're going to finish off our unit on solutions with something called acids and bases. So today we will be able to know the difference between acids and bases, and then also be able to determine something called the pH of a solution through charts, pH and indicator charts. Okay, as you'll see here, no star today. I kind of want to just go straight into it, but we will start off with a question of the year, not of the day, of the year, and some announcements. I want to start off this lesson with a demo, and then we'll go straight into our lesson to the acids and bases, some quick notes, and then we do have a closer. So instead of the starter, we have a closer today. For assignments, it's the last class, so there's really none. Yeah. All right, so let's begin. So first question of the year, you can say it out or you can write it in our chat. What was one of your favorite things we did in chemistry this year? And I'll write it here as well. So question, what was one of your favorite things we did in chemistry this year? It can be a lab, it could be an experiment, it could be something that you learned or something you didn't know. One of your favorite things we did in chemistry this year. Or maybe it was just like experiences. You just like being with a lot of your friends in this class. Nice, the fire bubbles, the methane bubbles. Hey Scarlett, thanks for joining. We're just trying to answer this question. What was one of your favorite things we did in chemistry this year? If you can say it or write it, that'd be great. So we'll give about maybe 30 seconds to a minute as people are writing things down. Hi Adelia, people are writing down what was one favorite thing we did in chemistry this year. Maybe it was an experience. You can write it or you can say it. Awesome, so let's recap. Benjamin says the methane bubbles, lighting them on fire. Scarlett says the clear liquid in the beaker that would turn blue or yellow. Nice, that was one of the first demos we did, if I'm not mistaken. You're gonna like the demo we do today. Jacqueline says one of my favorite things from chemistry this year was just being able to have labs with friends. Nice, so just the experiences with being with your friends. Awesome. All right. That being said, in terms of announcements, so I wanted to talk a little bit about grades and end of school year, just to be clear that you know what's going on for next week. So next Friday is when I'm turning grades in terms of grades for second semester. Remember that the San Jose Unified District has made all semester 2 classes be pass or no pass. So all of you that are here with me right now is 60 and above, and I know some of you are not even close to being 60%, but you are passing and getting credit for the class. Okay. In terms of next week then, I just want to have kind of a quick comment here, because I know it's small, but maybe you're interested and maybe you can get your friends to come if this is something you want to see. But usually, as a tradition, my last day of class, like during finals week, I always show a movie. You'll notice that I actually don't spend any time throughout the year doing any types of movies. So on Tuesday, I'm just wondering if people still want to show up, and I'll just screen one of the movies. I also get this a lot of requests throughout the year. If you remember at the beginning of the year when I present myself and introduce myself, I tell students that in college, for a very small part of my college years, is I spent some time in a dance group, and people sometimes want to see that dance video. I can show that on Tuesday. But yeah, I'm just wondering, what are your thoughts? The movie that, if we do end up saying you want to watch a movie, will be October Sky. October Sky is about these 4 kids trying to, I guess, make something of themselves so that they can kind of move out of their town. And the way that they do that is through making rockets. So it's pretty cool if you're interested in that kind of stuff. Or maybe you just want to see my college video so you can see me embarrass myself. So I just want some quick thoughts. You can say it or put it in the chat. Any thoughts for Tuesday? So maybe watch Mr. David embarrass himself with the dance video. Maybe you want to watch October Sky. Or maybe it's just nothing. I bring this up for those of you who just came in. I always just end the year with just something relaxing while people are studying during finals week. And I've always showed these 2 videos. One is the dance video that I mentioned at the very beginning of the year. And we also watch a movie, October Sky. If you've never seen October Sky, it's about rockets. It's about growing up. You want to watch the dance video? Can we watch both? Alright, cool. So, Tuesday then, I will show the dance video first. It's about 7 minutes long, I think. And then I'll put October Sky on afterwards, okay? So for people who just want to watch the dance video, then do that. Yeah, get your friends to show up so that you can. It's always cool to see a different side of Mr. David and get to see him embarrass himself trying to learn some dance moves. Okay, so that will be for next Tuesday. Cool. All right, let us start off with a demo, and you might see at the top demo ? So let's just go straight into that. I did this today. Let me fix my sound and then we'll watch the video. Hey everyone, Mr. David again. Throughout this whole Everyone, Mr. David again. Not loud enough. Alright. Watch very careful. Everyone, Mr. David again. Throughout this whole year, I've been doing a lot of demos. Today, it looks like we have another demo, but actually it is not. I'm going to show you one of my cool superpowers today. If you remember at the beginning of the year, particularly Unit 4, when we were learning about colors, I showed you that first image of that social media filter, the person vomiting a rainbow, and it told me the story that while I don't really follow social media that often, I do know that filter because I thought it was really funny, and I was really bummed out when they removed that filter. So I spent a lot of years trying to figure out how to bring it back. So I'll show you what I mean in just a moment. So I have a demo, or not really a demo. I'll show you my superpowers, okay? And the fact is, I have the ability to vomit the rainbow myself. All right, so I'll show you what I do. Red. You might think, oh, well, you can only just do one color. That's pretty interesting. I think I want blue this time. Blue. Now you're wondering what's going on. I think this one I want green this time. Last but not least, it's really taxing on me, so as this goes on, the colors start to kind of fade away, and my powers go away as well. But I'll try to get this one. I think I could get yellow. So, the rainbow, red, blue, green, yellow. I don't know about you, but using superpowers is really taxing on me and really draining. So, as always, always drink your fluids so that you can replenish yourself. Bye, everyone. All right, so start off with that demo, and yeah, hopefully you all like that. And then yeah, if you have your response, what the heck, how did he do that? Well, I'm glad that you're here so that we can start learning about how I did this throughout this lesson. Okay, so Unit 12, Solutions in Acid-Base Chemistry. And our essential question today is, what makes a chemical acidic or basic? All right, we're going to go straight into it. I also color-coded everything in this lesson. Acids will be red, bases will be blue, and throughout the next few minutes you're going to learn quickly what these things are. All right, so just really quick, I want maybe one or two responses. What do you notice about all of these acids? Remember, this whole year I've been trying to have you figure out patterns. So all of these 8 chemicals are called acids. What do you notice about them? Maybe in how they're named, or maybe in what something similarities you see in their chemical formulas. Awesome. On the chemical side, Jacqueline noticed that all of them have hydrogen in all of them, the H. Does anyone notice anything about the name? It should be pretty obvious. I think Anthony's writing it. Awesome. And then you notice the endings is like ic or OUS, and then ends with acid. Yeah, so when we name things in acids, we call them what they are. They're acid. So HCl we call hydrochloric acid, nitric acid, sulfuric acid. So in chemistry, we know if it's an acid or not. And then Jacqueline said they all have H's. Okay, so all of these acids have hydrogen, and specifically they have this hydrogen ion. We learned about ions at the very beginning of the year. So this ion will be really important when you see this in the next slide. Okay, so acids are substances or chemicals. Maybe I should put chemicals here. Whoops. Acids are chemicals that are able to break down to give H plus or hydrogen ions in aqueous solution. So when they are mixed with water. So when you add an acid, which is you'll typically see them in water type of solutions, they will break down to give H plus hydrogen ions. So what does that mean? So here's an example. HCl is hydrochloric acid, and it's going to break down. So you can even try to see what it breaks down into. But it breaks down into a component that is H plus. So that's what makes it an acid. And then kind of like Legos, if you break something that is two pieces and you break them apart into its own separate parts, you'll also get the remaining things. So H plus, and then the remaining is Cl, and then notice how the charges have to balance each other out. So Cl minus, so H plus, and then the rest that breaks apart is the rest of the chemical Cl minus. Let's see this one more time. Acetic acid. So acetic acid is the chemical that is found a lot in your vinegar. So if you're looking in your pantry and you look for vinegar, the thing that gives it that sourness is acetic acid. Acetic acid has the chemical formula HCH3COO. Why is this an acid? Well, it breaks down into H plus. So one of those H's is going to break apart from the rest of the chemical. And if H is positive, that means the rest of the chemical that breaks off has to be negative. So notice how the H plus separates.
I'm in class.
Into CH3COO minus. And that's kind of the trend for acids. Okay. All right. Now let's look into the bases. So just like before, what do you notice about these bases? Ready, go. Something about either the way that they are named or their chemical formulas. What do you notice about these bases? So these were acids above. What is similar about bases? Awesome. Jacqueline found the hydrogen before. These ones all have hydroxide. Do you mean the name or the chemical, Jacqueline? I think Anthony's saying something too. The chemical. Yeah, so they all have hydroxide, the OH. We learned about this when we were learning about naming. Yeah, exactly. The polyatomic ion, the OH, and then in the naming it also says hydroxide. Okay, so they all have hydroxide, which is the polyatomic ion OH minus, and then in the names we typically call them hydroxides. There are many different bases and acids, of course, that we didn't mention and that you probably are familiar with when you start looking at things in your kitchen. But for the most part, they're really, really strong bases, and the strong acids we are typically follow this type of this format. Okay. So just like acids, bases are their counterpart. Bases are chemicals or substances that are able to break down to give OH minus, and we call these hydroxide ions. We already were able to find that these are polyatomic ions. We learned in naming. And again, if they are in a water or aqueous solution, they will break apart into that. So again, here's an example. NaOH, sodium hydroxide, is a base. It's going to break apart into Na plus. And the only reason I did that first is we typically read left to right. And then you will see the OH minus is the thing that makes it a base. All right, so the OH minus makes it base. And the OH, we learned, stays together. So you might say, well, why isn't it an acid? Couldn't it break apart into an H? It doesn't mean that bases can't have H's in it. It's just that the H plus is very different than the OH minus. So if there's an H, try to see if there's an O right next to it, because those hydroxide polyatomic ions tend to stick together, and they definitely do here. All right, so big picture, I hope that you learned something about acids and bases today. So what makes something acidic or basic? So let's take it way, way, way old school, way back, BC. The ancient Greeks classified chemicals as acidic or basic by their taste. So, by their taste. So they found out that a lot of their chemicals that were acidic or were acids tasted sour. And that kind of makes sense. So if you think about things that are sour, what are the things I can think about? Lemons are quite sour, and of course its lemonade counterpart. And if you look at anything you've ever eaten that is sour, and you look like, especially if you eat candy, take a moment, check to see the ingredients. I promise you'll see the word acid somewhere in one of those chemicals. Bases, on the other hand, they taste bitter. I can't really think of an example right now that would taste bitter. But if you've ever said a bad word and your parents have an old school way of disciplining you, which is to, wash your mouth by biting into a bar of soap. I know friends who did that. My parents didn't do that. Maybe it's because I didn't say any bad words. But soap definitely tastes bitter. Okay. As you can imagine, though, if they are testing things by taste, a lot of people died testing these chemicals. But hey, back then, I guess what other option do you have if you don't have extensive technology? But yeah, a lot of people died testing chemicals because they tasted them. And I hope that throughout this year you've learned that while there are a lot of chemicals that don't really do anything, there are a lot of chemicals that definitely have a harmful effect on you. And maybe you learned a lot about that from last Thursday when you read the article about I think it was about caffeine and other chemicals. Well, we don't live back in ancient Greek times. We can do much better than that. We have a lot of technology. I don't want to go much into the details, but we have a lot of instruments now. We have a lot of we just have a lot of ways of detecting things, right? So I'll kind of summarize how we can do this. We can classify acids as the concentration of H+. Last Thursday we talked about solutions and concentration. I gave a lot of examples with Kool-Aid, that it's concentrated in sugar. Well, acids are going to have a high concentration of H+, that their chemicals are able to break down into H+. And bases, their counterpart, are able to know that by the concentration of OH-. So it should make sense that acids break down to H+. So the more that they break down into H+, it seems like it's an acid. For a base, as the more that it breaks down into OH-, we consider that a base. So let's talk about this thing called the pH scale. Chemists have developed the pH scale. I emphasize the H because it talks about the strength of acids and bases by the concentration of H+ ions. So notice there's no OH. So when we talk about acids, it's kind of weird and it's kind of counterintuitive when we think about these numbers. But a low number or a low pH tells us a very high concentration of H+. So when that number is really low, that means that it is very acidic. We also can use the pH scale to measure bases. So while pH, its focus is on acid, we can also think about it as the lack of H plus to talk about the strength of bases. I hope that kind of makes sense as you see this more. So a high number or a high pH indicates a low concentration of H plus, which means that it is by default base. I hope that makes sense. If there's a lot of H plus, it's a lot of acid. Well, the opposite of having a lot of H plus is having a very small amount, which means that it probably is basic. Okay. And then right in the middle, a pH of 7, so I'll show you the scale in a moment, indicates that it is neutral, neither acid or base. All right, so here's our pH scale that tells us how strong an acid is or how strong a base is. And it ranges from 1 to 14. So here on the left side, you'll see the acid side, 1 to about 6. Right in the middle is neutral. So for example, your drinking water is perfectly in the middle at 7, neutral. And then on the right side, above 7, going from 8 to about 14, we call this a base. Notice here sometimes people call it alkali to also mean base. Okay, so maybe I'll make a note here. Alkali equals base. So I mentioned this before, I think, but there was a really big trend a few years ago about people drinking alkaline water, and the people who were trying to make money off of people gave the reasoning that, well, your stomach is very acidic, which it is, but it's not acidic in a way that is dangerous. Actually, it needs to be acidic because that's how your stomach functions to like destroy any type of weird bacteria or any foreign substances that your body takes daily. But they tried to scare people in saying it's not supposed to be acidic, and a way to neutralize that is by drinking basic water, which they call alkaline water. So I won't go into the details behind that, and I'd like you to make your own decisions whether you drink it yourself or not, or maybe friends or family. All I can tell you is that I wouldn't waste the extra money if you think it's going to help you. If you think it's fine and you can support that extra amount of money to pay for that quote-unquote alkaline water, feel free. But I will let you know that it's knowing the chemistry behind it, I'm not. So you make your own decisions, okay? All right, cool. And then last but not least, we're going to learn about these things called indicators. Indicators are a visual way to determine pH. A lot of the chemicals we use this year have no color to it at all. So we don't want to be like the ancient Greeks. We don't want to taste it and say, oh, that tastes acidic, and then realize that is very harmful for our body. So we need a way to be able to indicate visually how strong is this chemical or not. Okay. So indicators are chemicals that can determine the pH of a solution visually. And just like the word indicator, it has the word indicate in it. What do? They indicate whether it's an acid or a base. How does this work? Well, visually, they are going to change color based on the pH of the chemical that you are testing. So, for an example, flavin is a chemical It is also found in chemistry that it is an indicator. And what's cool about flavin is that it's probably in your refrigerator right now if you have red cabbage. So this is an indicator found naturally in red cabbage. Okay, so what does it do? Well, just like all indicators, it will change color of a solution or chemical based on the pH of that solution. So here at the bottom, at the top we have our pH scale going from about 0 to 14, and then on the bottom, and then you can also see it with the visual as well, is the colors that you do it here. So for example, if I added flavin to water, you'll probably get a in between purple and blue, more likely like a blue color. If I had a chemical that was very acidic or low on the scale, like maybe 0 to 1, it would turn red. And then maybe on the opposite side, if I added flavin to something that was very basic, maybe something that had a pH of 12, the flavin will turn that chemical green, and so on and so forth. It could turn yellow if it was even more basic. So here are some examples. How do I use the indicators? So please try to follow along. So again, we'll use our flavin, an indicator found in red cabbage, and again, it changes color. So if I add flavin, which is red cabbage juice, to lemon juice, it will turn red. What happened to my picture? Okay. Sorry. I'll just keep it up. So if I add flavin to lemon juice, it turns red. So what does this mean? This means, so when I use this indicator chart, because this is something we know, it's kind of like having the data in front of you, this means it has a pH of 0 to 1. And because low pH or below 7, we know that we call it an acid. So if you're ever wondering what lemon juice is, it is an acid. Lemon juice has acetic acid in it. It also mainly has ascorbic acid. So maybe you start realizing, oh, that's why it's sour. It has a lot of acid in it. On the other hand, if I add flavin to something like baking soda, it turns like a bluish aqua color. So this means, if I look at my chart, well, if it turns bluish aqua, that means it has a pH of 9, which is a base. So hopefully you start seeing how this works, right? So let's practice with two examples. At the top right, we have our pH scale. I know that when people visualize pH scales, they tend to make it colored as well, from acid like red to alkali blue, but this isn't what the color will turn into. The flavin indicator is indicated by this color. All right. So you can say this or you can write this. A student adds indicator to an unknown solution and turns green. I want you to tell me, what is the pH of this unknown solution, and is it an acid or is it a base? Ready, go. Student adds indicator to an unknown solution and turns green. What is the pH? Is it an acid or base? So I'll give you a few seconds to kind of reason this out. A student adds indicator to an unknown solution and turns green. What is the pH? And is it an acid or is it a base? Cool. So Anthony said, let's just read it. Student adds indicator, and then we're talking about the flavin indicator, and it turns green. Okay, so I look at my indicator chart. I look for green. At the top, it conveniently also shows the pH scale. So we know that this chemical had a pH of 12. And then if you look at the very top right, our regular pH scale, we're looking at 12. We know that it's on the side of the alkali, or alkali is another word for base. So this is a base. So perfectly, Anthony says it would be a base with a pH of 12. Let's do one more. Similar questions. A student adds indicator to a solution with a pH of 4. What will the student observe? And then again, is it an acid or base? So I love acids and bases in solutions because it's so straightforward once you know the tools that you have, such as the indicator chart and pH chart. And these are the types of questions that people typically have. So what will the student observe? Is it an acid or base? Let's try to get this, and then we're pretty much done for today. Alright, so first we look at the indicator. What does the indicator do? Indicator changes color. So, if this person adds indicator to a solution that I know has a pH of 4, and we can do that, we should observe and predict that it will turn a dark pink color. Okay? And then we go back to our regular scale from 1 to 14. We know that it's below 7, and the reason I keep talking about 7 is because 7 is neutral. It's neither acid or base. It is right in the middle. So if it's below 7, towards a lower number, we know that this is an acid. Okay, nice. Whoa, let me write these down. So pH for this one was green, so it's 12. Base. This one was observe color change to dark pink. It is acid. Right? So, my closer for you all then is, how did Mr. David do his demo at the beginning of class? Brainstorm. How did Mr. David do his demo? Try to explain the parts that you saw in the video. And while you are thinking about that, I'll try to bring it up as well. And then you don't need to hear the sounds, but you can kind of see it all again. How did I do this demo? You might think, oh, you can only just do one color. That's have the ability to vomit the rainbow myself.
It's kind of like a puzzle. It's like a
I'll show you.
a brain teaser. Break down everything you see, and now with the 20-30-ish minutes of chemistry that you just learned,
I think I want blue this time.
how did I do this demo? Or do I really have magical powers?
Now you're wondering what's going on. I think this one I want green.
Maybe if one person starts saying one thing, people can start piece together all of the different things.
And last but not least, it's really taxing on me, so as this goes on, the colors start to kind of fade away, and my powers go away as well. But I'll try to get this one. I think I could get yellow.
Different pH in every wine glass. So what do you mean, Noe? Can you say more to that?
So, the rainbow, red, blue,
Or can
green,
someone else add to that?
yellow.
So Noe has
I know
a
about
very
you
good
for
point.
using superpowers,
Different pH in every
really
wine
taxing on
glass.
me.
I will say yes,
So,
but what does that
as
mean?
Always drink your fluids.
What does that mean in
and,
terms of what I did to the wine glass?
what I mean in just a moment. So, I have a demo, or not really a demo. I'll show you my superpowers, okay? And the fact is, I have the ability to vomit the rainbow myself. All right, so I'll show you what I do.
Because what Noe said is very true.
Red. You might think, oh, well, you can only just do one color. That's pretty interesting. I think I want blue this time. Blue.
This is actually the first time I've ever seen myself
I
do the
think this
demo.
one I want green this time. Last but not least,
Alright,
it's really
Anthony's saying
taxing on me,
something.
so as this goes on,
I'm curious what he
colors
would say.
start to kind of fade away, and my powers go away as well. But I'll try to get this one. I think I could get yellow. So, the rainbow, red, blue, green, yellow. I don't know about you, but using superpowers is really taxing on me and really draining.
I'm excited. Alright. The quote unquote water is either an acid or a base. And the liquid you put in your mouth in your water bottle has an indicator, probably flavin. Cool. Nice. So putting both of your stuff together, this is how I did this. So in the wine glasses, if you watch the video again, I actually never say anything about it being like completely empty. But the way wine glasses are is you actually can't really tell if it was empty or not. But it was not. At the very bottom of each wine glass, and it looks like there's nothing in the glass because all of the chemicals I used were very clear. So that's kind of what I wanted Noe to say more about, or someone else to say more about it, is that in each wine glass I put a different chemical. And as Noe said, each chemical has a different pH. The stuff around your house, so this one was actually cool because I was able to do this at home, ranged from either really acidic or really basic. So let's look at these colors, okay? And then Anthony has the other thing. In my water bottle is actually red cabbage juice. So you might be wondering, well, how did he drink it at the very end? And you might ask yourself again as well, did I actually drink the cabbage juice? And yes, I did, because I wanted to make it dramatic for the theatrics of the video. I did drink red cabbage juice. It's just water that tastes like cabbage. So if you look at all of our indicators here for flavin, on the left here I have red. So that means I used a chemical that was very acidic. The thing that is quite acidic in your house that is okay is vinegar. Vinegar is very acidic. It's acetic acid. It was one of those lists there, and it turns red. Okay. In the next glass, it turned blue. Blue, you'll see on the indicator chart, it's around 8-ish. So actually not too basic. It's very close to being like water. This was actually a type of cleaner I found underneath our sink. So like soaps, those types of solutions are typically not too are not really that acidic. Actually, it's not at all. It's more on the base side. But even so, it's 8. It's very close to 7. Not really a strong base either. Okay. In the third wine glass, this was really hard for me to find because when I do this at school, it's really easy. I have all of these chemicals. I know what they are. So here I actually had to test around. So I added a bunch of chemicals, different chemicals, and I wanted to see, can my indicator turn it green, because I wanted, a very dramatic range of colors. So green, I found was a disinfectant. So all of the disinfectant you've probably been using the last month or so during the quarantine, it turned it green. It's fairly basic. So around the 11 to 12 range. So we look at our pH scale. It's towards the high end of 14, so we know that is a base. And then all the way to the right side, bleach. Bleach is very, very, very basic. As you can see here, it turned yellow. And we look at the scale at the top right. It's at a scale of 14, so we know this is one of the strong bases. So don't think of strong acids and bases as like something that is not, found, that it's very hard to get. You just need to know that all around your world, especially in your kitchen, can be either really acidic or really basic. If you want to try this, experiment at home, just type in red cabbage indicator. Basically, you boil red cabbage in a pot. You can see the pot on the stove. And then you add that little liquid to different chemicals or things you find around the house and see how it changes its color, if you're ever interested in how that works. Okay. Cool. I hope some of you learned some cool things today. And we are done for today. I'll put this recording later. If you want to see the rainbow demo, my versions where I pretend I throw up, the original version Tyler DeWitt does. He does it with a tea kettle. You don't know that the indicator's in there, and then he just says, "Oh, I want this to turn different colors." But I like my version because in high school, people want to see the cool theatrics. In terms of the assignment, there's none. There's nothing else. If I do not see anyone again, or you don't come by next week, just know that I hope that you all have a great summer. I wish I would able to say like a even more sentimental speech, but it's very hard online. But just have a great summer if I don't see you all in the next few days or week. Benji says I still do magic. That's great. I like hearing that stuff.